So we will be looking into problem solving today, okay, for refrigeration cycle. We start off with reverse Carnot cycle. Okay, so please pay attention. Now, pressure in the evaporator of an ammonia refrigerator is 1.902 bar, and the pressure in the condenser is 12.37 bar. So I hope everyone have done your revision. Okay, so this will be your low pressure, which is the evaporator pressure, and this would be the higher pressure, that is the condenser pressure. So based on reverse Carnot cycle or ideal vapor compression cycle, you have two pressure limit. One is the highest pressure and the other one is the lowest pressure. So the lowest one always refers to the pressure, and the highest one always refers to the condenser pressure. So the question asks us to calculate the refrigerating effect, that is RE, or the cooling effect per unit mass of refrigerant, that means per kg of refrigerant, and the COP, the coefficient of performance for refrigeration for the following cycles. No heat pump, yeah, refrigeration. So based on the first one is based on your ideal reverse Carnot cycle. So the first part will be based on ideal reverse Carnot cycle. So this is your reverse Carnot cycle on the TS diagram. So you have condenser pressure, that is the higher pressure, and the lower pressure here, okay, will be evaporator pressure of 1.902 bar, this pressure here. And this pressure here would be 12.37 bar with respect to this temperature TH and the TL. So for any Carnot cycle, the most important thing is we have to know the temperature TH and the temperature TL. So to find temperature TH, you need to refer to the property tables, okay, under ammonia as refrigerant. So you look for pressure 1.902 bar at the pressure of 12.37 bar. So the saturation temperature based on 12.37 bar plus 273, you have pH. And then based on the evaporator pressure of 1.902 bar, the saturation temperature plus 273, you will have the TL. And then please remember that you have to also find the S1 or the S2. For this case, don't go for 0.1. Straight away find out S2, which is also equals to S1. And then S3, which is also equals to S4. So my advice is straight away find S2 and also S3 at the pressure of 12.37 bar. So the entropy Sg, because this point here sits on the dry saturated vapor line, and point 3 sits on the saturated liquid line. So now you should know that if I want S2, S2 will be equals to the Sg at this pressure. And then S3 would be equals to SF at this pressure. And this would be the schematic diagram where you have the compressor, the condenser, turbine, and evaporator. That's for reverse Carnot cycle. We have turbine. Okay, so that is state point 1, that is inlet to the compressor. State point 2, which is the outlet of the compressor after undergoes isentropic compression, where the pressure and temperature of the vapor refrigerant or the wet vapor refrigerant or the saturated liquid and vapor mixture refrigerant is being compressed to higher pressure and temperature. Then it enters the condenser where it undergoes constant pressure heat rejection. That means it is being rejected to the surroundings. Okay, so constant pressure heat rejection here. Okay, the heat will be rejected continuously within the condenser, and then it comes out from the condenser at 6.3, which is the saturated liquid as shown here, sitting on the saturated liquid line. Then it will go into the turbine where it undergoes isentropic expansion. And so what happens here is that the pressure and temperature of the refrigerant will be lowered, okay, to TL, and as well as the pressure. So the pressure will be lowered from the condenser pressure to the evaporator pressure as in state point 4. Then it will go back to the evaporator where it undergoes constant pressure heat absorption. So within the evaporator, everything is changing from liquid, more liquid or less liquid, more liquid to less liquid. Okay, so there will be a change in phase taking place while heat is being absorbed. So remember, in the evaporator, the temperature, okay, before going into the evaporator, the temperature will be lowered down. And then in the evaporator, phase change is taking place at constant pressure. So you have a continuous heat absorption, so the temperature inside is always maintained constant. So this is the TS. So state point 2, we start straight away at state point 2, because when we do reverse Carnot cycle, we know that to find heat absorption and heat rejection, here is heat rejection, we need to find the area of this section here. Okay, to find heat absorption or RE, we need to find this area here. So what is involved is the temperature and the entropy. So at state point 2, which is sitting on the dry saturated vapor ammonia or refrigerant, at this pressure, remember dry saturated, you see it is sitting on the saturated vapor line. So if you want to find H2, you can straight away or directly from the property table find out the G, which is at 12.37 bar. That will give you 1469.9 kilojoules per kg. For the time being, we are not making use of the H2. And then S2 is the same dry saturated because it is sitting on the dry saturated vapor line here. So it's equals to SG at this pressure 12.37 bar. So from the property table, SG at this pressure, you will be able to find your S2 is 4.962 kilojoules per kg. Then from the table for ammonia, we are referring to ammonia here, which is NH3, and refrigeration code is refrigerant or R717. So from both the property table, you will have the values or the data for the refrigerant ammonia. So now this pressure here, point 2 is at 12.37 bar. So look for 12.37 bar. This is your pressure. 12.37 bar is here. Okay. Then the Hg is here. And the Sg is here. Okay. So you see here, 12.37 bar. Remember, we need the temperature. We need the temperature here. This TH here. So this TH will be 32 plus 273. So the SG will be this value here. Don't look at these two parts here yet because this is only for superheated. Okay, so look at this, 4.962. Yeah. Okay. Then for saturated liquid at state point 3, okay, which is also at 12.37 bar. Okay, so you have 12.37 bar here. SF is 1.235. SF is 1.235. Okay, we don't refer to this yet. This is based on 1.902 bar. Okay, we are not looking for the dryness fraction at both of these points. Okay, so we straight away make use of this at 2 entropy to find out the QH and the QL. Okay, so that is based on 1.902 bar, the evaporator. So means something extra here. Okay, sorry that. Okay, so that would be the pressure because I need to list down all the properties. So that is why I refers to the ammonia side 1.902 bar. So make use of this for the later section of the question. So 1.902 bar. So you can list everything here that you want. Okay, and then tabulate everything or place everything in this table here so that working will be much easier. Okay, so remember RE or QS. RE is the refrigerating effect. Why are QS here? Because it's the heat supply to the refrigerant. That means it's equivalent to the heat absorption actually. Okay, so this area here. So this height here is EL. The base here is S1 minus S4. See? Or you can consider S2 minus S3, which is the same. S2 is equals to S1. S3 is equal to S4. So you can use either this or this will give you the same thing. So the TL, okay, the TL, okay, I need the TL because I need to find this area, okay, I need to find the area. So TL here, so TL is at negative 20. I need to find this area. So that means I need to know this height. So that is why you refer to this pressure 1.902 bar. That is the evaporator pressure, which gives you negative 20 saturation temperature. Then you add it with 273 for the absolute temperature of TL. So then multiply by the change of entropy, which we have found, okay, S1 and S4, okay, or S2 and S3, S2 and S3, or S1 and S4, also the same. So you will find RE, you can find RE 942.9. So that is your RE or the heat absorption. Then the next thing is, because the question did ask us to find RE, right? So, and then the next thing is COP for refrigeration. So according to reverse Carnot cycle, which have proved, okay, that the COP for the refrigeration is TL over TH minus TL. So the TL is this. The TH will be your 32, which is at this pressure here. Okay, this pressure is 12.37 bar, which is at this temperature 32 plus 273. Okay, so the TL is at this pressure here, 1.902 bar, and the temperature here is negative 20 plus 273. So you will be able to find COP for the reverse Carnot cycle, which is 4.87. So the RE, the question asks us to find RE and COP. So that is solved. Okay, so that's for this part. See you in the next section. Thank you.